Hello, hello. Today we shall be developing panel VECM model, and here we have 6 countries. We have 6 countries, and the data is from 2000 until 2010, and so on. Okay, but first we have to develop panel unit root. That is our first job. Second job, we shall develop a co-integration test by Fisher Johansen test of co-integration. And then finally we shall develop the panel VECM model, and finally we shall do the wall test. So there are 4 things. So first one would be panel unit root test, then Fisher Johansen test of co-integration, panel VECM model, and finally wall test. Okay, so here we have the data. The data is here for 6 countries. You can see the data, all the data here. Okay, I'm opening as a group. All the data is here. Open as a group. Okay, so there are 6 countries. This is country 1, right? Then country 2. This is panel data, right? Country 3, country 4, country 5, and country 6. 6 country and data from 2000 until 2010. And here there are 2 variables. One is export and one is GDP. There are 2 variables in total. Export and GDP. Okay, and the topic of this thing is what? The topic is testing the link between GDP and export, right? Testing the link between GDP and export. Okay. Okay, now, okay, so first we develop the panel unit root test. Okay, so I go to my variable. Okay, first I start with export, right? Export variable. I click on the quick, then series statistics, unit root test, right? That I do, press. Then I put the variable export. Okay, and here is summary. Here I select summary, and here I select none, meaning that there is no intercept and no trend that I assume for the time being. This variable does not have intercept or trend that we assume, and it is at label, right? At label I select, and I select automatic lag selection. Okay, so we are set, we are done. Then I proceed with the OK. Okay, you can see this is the panel root summary, and the variable is export. And what is our null hypothesis? Null hypothesis is there is unit root. And what is alternative hypothesis? There is no unit root, meaning that data is stationary, right? Okay, so there are few methods. You can see there are methods, right? One is Levin, Lin, Chu, ADF, and PPP. Okay, so first I check about Levin-Lin-Chu method. It is the statistics and corresponding p-value. P-value is how much? 87.92%, which is more than 5%. So we cannot reject null hypothesis, meaning that the export variable has unit root. Okay, then what about the ADF statistics? This is statistics and p-value 97.57%. We cannot reject null, rather we accept null hypothesis. And PP Fisher, also we cannot reject null. So what does it mean? That there are three methods. They are telling that export has unit root at level. Okay, now I check. What happens if this export, uh, uh, converted into first difference? Then what happens? I go to view, then I go to unit root test as before. Then here I select first difference. Here I select first difference, and others are remain unchanged. Only I change here. I choose first difference of the export variable. Then what happens? Click OK. You can see de-export. That means the variable has been converted to first difference. Okay, what about this one? Levin-Lin-Chu test. The probability is very small. That means I can reject null hypothesis. And ADF test, yes, I can reject null hypothesis. What about PP test? I can reject null hypothesis. What is the null hypothesis? The variable is got unit root, but I can reject the null hypothesis. It means that this variable does not have unit root. That means the first difference of export does not have any unit root. So what I can say? I can say that, I can say in other way, our export variable, is what? Is I1. What does it mean? I1 means the export variable is non-stationary at a level, but when I convert the variable into first difference, then it becomes stationary. So I'm telling again, this export variable at a level, it is non-stationary, meaning that it has unit root. But when I convert the variable into first difference, it does not have any unit root, meaning that stationary. Okay, so that is why export variable is I1. Okay, now we have the second variable, that is GDP. What happens to GDP? Okay, okay, what happens to GDP? We can check it. Where is our file? Okay, it is GDP, right? That is GDP. As before, I click on the quick, then the series statistics and that test for unit root. I select it. Then I put GDP. Okay, I put GDP as before, then enter. Okay, okay, here as before, I take summary, and here I take label as before, and here I choose none. That means this GDP variable we assume does not have any intercept or trend. Then I select this one, automatic lag selection. Then we are done, we are ready, we proceed with the OK. Okay, so this is the GDP. Okay, what is the null hypothesis? There is a unit root. That is the null hypothesis. Okay, first I check the Levin-Lin-Chu test. I cannot reject null hypothesis, meaning that there is a unit root at level. Then ADF also I cannot reject null. PP I also cannot reject null because p value is 99.88%, which is more than 5%. So meaning that GDP variable at level got unit root. That means non-stationary. Okay, now I check what happens when the GDP variable convert into first difference. I go to view as before, then check the unit root test. Then this thing is remain unchanged. This is also remain unchanged. I just bring a change here. I just put first difference, right? First difference, I put it, then okay. You can see DGDP. That means first difference of GDP. I check Levin Lin Chu test. The probability is zero, almost zero, meaning that I can reject null hypothesis. An ADF test, yes, I can reject null hypothesis. What about PP test? I can reject null hypothesis because p value is extremely small. Okay, meaning that the first difference of GDP does not have any unit root. That means it is stationary. So in that case, our GDP variable is what? Sorry, our GDP variable is also I1, meaning that GDP variable at the level is non-stationary, but when I convert the variable into first difference, then it becomes stationary. Okay, here you can see export and GDP both are I by 1. So meaning that they are integrated of same order, right? And when the variables are integrated of same order, we can run the co-integration test. And here in this model, we shall apply Fisher Johansen co-integration test, which is system based. Okay, so as the variables as the variables both are integrated of same order, we can run the co-integration test, and we are running Fisher Johansen test of co-integration. Okay, so I go to quick, then I go to group statistics, then I select Johansen test of co-integration. So that I select, it is here, right? You can see it, click on it. Okay, here I put my two variables, export and GDP. So these two variables actually here, these two variables here is non-stationary because co-integration test need non-stationary data. I click on it. Okay, here are actually three tests. There are three tests for test of co-integration in panel data. So here I choose this one, Fisher-Johansen test of cointegration that I choose. I select this one, and here suppose I select option 4. Option 4 I select, and here I choose lag 1, and which is optimum we assume for the time being. We assume lag 1 is optimum. Then we are done, we are set. Then I press OK. Just a minute. Okay. Johnson-Fisher test of cointegration. Okay, here there are two series export GDP. You can see from here. Okay, there are two tests. One is the trace test, and one is max eigen test. And it is the null hypothesis, none. That means there is no cointegrated equation. Number of cointegrated equation. It is called number of cointegrated equation. That is the null hypothesis. Number of cointegrated equation. Suppose it is none, meaning that there is no cointegrated equation, or our two variables are not cointegrated. Okay. Now the first is this one, trace test. This is the value and corresponding p-value, and 41.80. This one is the statistics value for max eigen test, and it is the corresponding p-value. So you can see from here, both tests can reject null hypothesis. And what is our null hypothesis? The null hypothesis is none, meaning that our two variables are not cointegrated. So we can reject this hypothesis. Okay, then when we can reject this hypothesis, we have to come here, at most 1. That means there is at least one cointegrated equation, at least one, at most 1. Okay, and it is the trace test and the p-value. It is the max eigen test and corresponding p-value. But here you can see the p-value is very large, 19.21%, and here is also 19.21%, which is more than 5%, meaning that we cannot reject null hypothesis, meaning that there is at least one cointegrated equation in this model. In other words, these two variables, export and GDP, are co-integrated. Okay, so export and GDP are co-integrated, and when the variables are co-integrated, we can run the panel VECM model. So I'm telling again, when the variables are co-integrated, we can run the panel VECM model. Okay, so excuse me. Okay, now go to quick, then go to estimate var. Then I select vector error correction model, right? Panel vector error correction model, and here I click this one, right? And here I select 3. Suppose I select 3. I assume I select 3 option. Go to basic. Okay, here first I put export as a dependent variable. Make sure first I'm putting export here, and then GDP, right? So make sure first I put export, then GDP, and here we assume that lag 2 is the optimum for this panel VECM model that we assume. Okay, then we can run the model by taking export is the first. Click on it. Okay, you can see this is the vector error correction model, right? And we have taken 2 lakh, and it is the error correction term, right? This is standard error, this is t value. Actually this divided by this, you can get this t value. And you can see we have 2 lakh variable we have taken. So export 1, export 2, GDP 1, GDP 2, and C. And here is same thing. Coefficient divided by standard error, you can get t statistics. Coefficient divided by standard, you can get t statistics. And the first one actually is what? Is our model. Actually, the first one is our target model. The first one is our right model. So we shall consider only this first model because we put export first. So that is why this is our model, not the second one for the time being. For the time being, it is our model. Okay. Okay, but here in this model, you can see there is no p-value. Coefficient, standard error, and t statistics, but there is no corresponding p-value, probability value. So we have to know the p-value actually. Okay, so question is that how to get p-value, how to see the p-value. So I have to go to proc, make system, then order by variable, right? I do this one, select. Okay, you can see this is our model, right? And you can see this is what this is a system model. System model means you can see C1, you can see C2, C3, C4, C5, C7, sorry, C6, C7, C8, C9, C10, C11, C12. So there are 12 coefficients actually in the whole system. Okay, now we have to estimate all the coefficient from C1 until C12, right? From C1 until C12 we have to estimate. And from here to here is what? This one? This one is actually called cointegrated equation, right? And it is the C1 is the coefficient. Okay, now we have to estimate the whole things. Okay, click on estimate. The icon is here. I click on it. And this is the method or OLS method, right? It is here, OLS method. I click on the OLS method. It comes up. You can see there are 12 coefficient, right? And last time we had t value, but now we have p value. We have p value now. Okay, now. And we have two model. Equation 1, export is the dependent variable. And the second equation, dGDP is the dependent variable. But here, this model actually is our model to be considered because we have taken export as a dependent variable. Okay, now. Okay, here you can see what is C1. C1 actually error correction term. You can see from here, this C1. Actually, this one is the error correction term, C1. Okay, C1 is the error correction term, or I can call it ECT. Okay, so the thing is that what is the guideline? I'm sorry, I have lost it. Okay, what is the guideline? The guideline is I can write it, the C1, right? C1, The guideline is, what is C1? That is said, C1 is the error correction term. When the C1 is negative, negative in coefficient, negative in coefficient and significant, then we can say that there is a long run causality running from independent variable to dependent variable. Or also we can say, there would be a there would be speed of adjustment towards long run equilibrium, right? So meaning that there are two things. One could be that there would be a long run causality or speed of adjustment towards long run equilibrium, and it is C1, but provided the C1 must be negative and significant. Okay, then here I check what is going on in our model that we have just got. Where is our model? Just 5 minutes, just 1 minute. Where is our model that we have just done? Not this one. Where is gone? Not this one. Not this one. This one? Yes. Okay. Okay, here our C1 is not negative, and also the p-value is not significant, meaning that there is no long run causality running from independent variable to dependent variable, meaning that from here you can see, for this model, right? So the actually this model we have to consider only. So here it means that the GDP1 and GDP2, so there are two lag GDP variable which are independent variable. It means that the GDP variable does not cause. So meaning that there is no long run causality running from GDP to export. I'm telling it again, it means that there is no long run causality running from GDP to export. Okay, so this one is the long run causality. What about short run causality? Short run causality can be tested using wall test. Okay, and here you can see short run causality, and here so here you can see GDP lag 1 is attached with C4 and GDP lag 2 is attached with C5. Okay. Now we can set the hypothesis like this. I go to proc, then I go to view, then I go to coefficient diagnostic, then wall test, right? Okay, here I put like that C4, right? C4 equal C5 equal 0. That means C4 C5 jointly 0. That is the null hypothesis. That means it comes from here, C4 and C5, right? It's coming from here. Click on it. I click on it. This is a wall test, chi-square, statistics, and the value and the probability. The probability is very big, 77.47%, meaning that we cannot reject null hypothesis. meaning that C4 and C5 jointly 0, meaning that there is no short-run causality running from GDP to export. Okay, so what is the summary of this model? For this model, when export is the dependent variable, then there is no short run or long run causality running from GDP to export. Okay, so this one is done. Okay, then we can estimate the model again. Okay, quick, as before I go to quick, estimate var, vector error correction model. Okay, last time I put export first. Now I put GDP first and then export, right? So you make sure the story has been changed. Last time I put export first, then GDP. But now I put GDP first, then export. And the lag interval is 2 as before. I click on the OK, right? So this is my result, right? Okay, as before, this one is what? Error correction term, coefficient, and t-value. This coefficient divided by standard error is t-statistics. Coefficient divided by standard error is t-statistics. But there is no p-value, right? For this model, there is no p-value, right? It is the model, but no p-value. But we have to know the p-value, right? Okay, as before, I go to proc, as before, make system, then order by variable, I select on it, then I press yes. Okay, this is my model, right? Okay, now there are C1, C2, C3 as before until C12, right? So there are 12 coefficient. I have to estimate all the coefficient one by one. So I select on estimate. Here is estimate. I select on it. And this is the what method? OLS method. OLS method is here to estimate. I press on OK to estimate it. You can see there are 12 coefficient, right, as before. So last time we had only t statistics. Now we have also p value. And this is our two model number one, model number two. But here this time this model actually we shall consider, not this model, right? This model we shall consider because I put GDP first, right? Okay, now what is C1? C1 is the error correction term, right? Error correction term, this C1, and it is here. It is here, right? Okay, and this C1 is negative in coefficient and significant, 3.8%. So it is negative and significant, meaning that there is a long run causality running from independent variable to dependent variable, meaning that there is a long run causality running from export to GDP, right? Okay, then the second one, speed of adjustment. Yes, so you can see the speed of adjustment is actually exactly how much? 4.91% annually, because the data is annual data. So that means the whole system is 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 ge- is getting back. The whole system is getting back to long run equilibrium at the speed of 4.91% annually. So we can say also in this way, the whole system, right? The whole system is going back to long run equilibrium at the speed of 4.91% annually. Okay, now we check the short-term causality. So as before, you can see C4 and C5, right? These are the two coefficient attached with export 1 and export 2. As before, I go to view, then coefficient diagnostic, wall test, right? I select wall test and I put C4 equal to C5 equal to 0, right? So that is the null hypothesis. C4, C5 jointly 0, right? Short-run causality. I am testing here. I press OK. Wall test as before, chi-square value and the p-value. P-value is very big, 51.08%. We cannot reject null hypothesis. That means C4, C5 is 0, meaning that there is no short-term causality running from export to GDP. So meaning that the whole thing is like this. Just I show you. It is like that. Just to show you as before. I'm showing the mistake system. Just show you again. I show you. Meaning that estimate, right? Okay, this one. So meaning that export and meaning that there is no short-term causality running from export to GDP. Okay, what is the gist of this model? The gist of this model, excuse me, there is a long run causality running from export to GDP because C1 is negative and significant, but there is no short run causality running from export to GDP. And thirdly, the whole system is getting back to equilibrium at the speed of 4.91% annually. So that is the whole things, and I think we are fine. I'm done so far, and thank you very much for being with me. Happy New Year 2016. Good luck.